Before getting into Ethereum, we wanted to give you a quick refresher on the blockchain framework. This was covered in early lessons when we spoke about Bitcoin and will also anchor us as we progress through the Ethereum world. As you'll see, there are many similarities between these two blockchains, and a lot of your previous knowledge will be directly applicable as we explore Ethereum. Here's a quick recap on the list of components from the blockchain framework. In this video, we'll walk through the framework to make sure you're familiar with each of these steps and how they relate to one another. First, transactions. These are the basic atomic units of work submitted by a user to a node to be included in the next block. Next, the wallet, which contains a wallet address. The wallet address is like an email address that you share with others should you want them to send you cryptocurrencies like Bitcoin, Ethereum, and many more. Users send transactions to one another using wallet addresses. Before the network validates a transaction, it needs a signature. A signature is the process by which one signs their transactions before submitting it to the node for inclusion into the next block. After signing, the transactions enter the mempool. This is where all unconfirmed transactions are placed until mining nodes validate these transactions. All transactions in the mempool are waiting to be picked up by a node in the network. This network is distributed in nature, where everyone is able to download a copy of the ledger to their local computer. This makes it so that there is no centralized ownership of information and allows the network to determine which transactions are valid and which are not. The network achieves consensus by determining which transactions are valid. Consensus is the name for a group of algorithms that can be used to create a voting mechanism or a process for a given blockchain network. We've gone over some of these algorithms earlier, like proof of work, proof of stake, but there are many more. Once the network agrees, the transaction is placed in a block and hash is assigned. Hashing is a process of generating a digital fingerprint, also known as hash, by passing data or information to a hashing function. This helps us identify a block and know whether or not the information has been tampered with. If information has been changed, the hash will also change, which invalidates the block. A block is a container that holds a list of transactions to be added to the blockchain. Finally, these blocks are linked together using hash values into what we call the blockchain. This blockchain is a shared ledger where the blocks are chained together. It contains the entire history of transactions that have been made on the blockchain. This allows us to easily see which transactions are valid and not. So there's a couple of components we went over before in the blockchain framework. Moving forward, we'll see that all of this is very similar in Ethereum. That said, there are some important differences. Coming up, we'll go over some new terminologies to better understand what these differences are. This will help us as we transition into building our own Ethereum-based applications.